In this video, we are going to see verification of Thevenin's theorem for this given circuit. We need to find what is the current through 3 ohm resistor using Thevenin's theorem. For that, we need to draw the circuit diagram as given in the figure. So we need 3 voltage sources and 5 resistors. So we will connect all the components as per the diagram. Before implementing Thevenin's theorem, we shall see the current through this 3 ohm resistor. For that, we will connect the multimeter through 3 ohm resistor, ammeter through this 3 ohm resistor. After connecting ammeter, let us see the current through this 3 ohm resistor, which will be when we make the run, we have the current values minus 806.45 milliampere. So this is the value of current flow through a 3 ohm resistor. To verify with the Thevenin's theorem, initially we will remove this 3 ohm resistor and find the open circuit voltage called the Thevenin's voltage. So for that, again after removing the 3 ohm resistor, when we run the diagram and measure the voltage across the terminals, which will be minus 3.125 volt. So this is the open circuit voltage that we will take. And to find the Thevenin's resistance, make all the voltage sources as short circuit. After making the short circuit, we shall measure the equivalent resistance between the required terminal. That will be calculated as after making all the voltage sources as short circuit, we shall find the equivalent resistance between the required terminal. That will be calculated as 0.7875 ohms. So this is called Thevenin's resistance. That we delete this entire circuit and we need to draw the equivalent circuit, Thevenin equivalent circuit, by placing the Thevenin's voltage, that is called open circuit voltage, with the resistance, Thevenin resistance value. So that will be taken as initially we will take as the voltage source. That voltage is nothing but Thevenin's voltage in series with the Thevenin resistance, which is calculated previously. So here this Thevenin voltage is minus that is 3.125 volt. So we will place it here, then followed by the resistance called the Thevenin's resistance. So we will place the resistance. We will place the Thevenin resistance, whose value is place 3. So that value is 0.875 ohms. That is a Thevenin equivalent resistance. So after connecting these two components, we will connect the removed load resistance, that is a 3 ohm resistance. We shall connect here. So for which we need to find the current. So connect all the components. In addition to that, we will connect the ammeter to measure the current through this 3 ohm resistance. So here we will connect the ammeter, to find the current through this 3 ohm resistance. So when we run the diagram, we will measure the current through this 3 ohm resistance. So minus minus 806.45 milliampere. So here open circuit voltage, Thevenin resistance, and also we have the load resistance. So after connecting all the components, we have the current through this 3 ohm resistance, which is same as the previous value.